So I came across this question last night while I was teaching a student, and this got me thinking for some time. This question, on the first hand, it looks very difficult, but then it looks very easy, and then it looks again very difficult. So let me show you how to deal with this one. So 49k plus 1, it's supposed to be a very big number, and it should divide this sum, and the options are 32, 63, 60 and 65. So first thing which comes inside the mind is like we can interpret this sum as 49 126 minus 1 by 49 minus 1. This is just like summing a GP. So if you have this kind of a GP 1 plus 49 and till 49 to the power 125, you can just multiply 49 and you can rewrite this sequence, and you can subtract. So the first equation from the second one, and you will see that all these things will cancel out, and you will get 48s equals 49 to the power 126 minus 1. So you can write the sum as 49 126 minus 1 by 49 minus 1, which is this. Okay, fine. Then you can see that this thing 49 to the power 126 can be written as 49 to the power 63 squared minus 1, and then you can use the identity a square minus b square equals a minus b by and into a plus b. So you get this, and then you see that this is here, and it looks like this is a factor of the sum. So yeah, but we will have to prove that there is 48 down here, so we will have to deal with this also, because this thing might not be an integer. 49 to the power 63 minus 1 by 48, this might not be an integer. For this 49 to the power 63 plus 1 to divide this thing should be an integer. Okay, so on a closer look, you can figure it out that you can take this 49 and you can put it here like 49 minus 1, and you can club this expression, and you can figure out that using the same sum of GP, this thing can be broken down to this, and this indeed is an integer. So we have proven that 49 to the power 63 plus 1 divides this sum. But the question is like the greatest positive integer, okay? Greatest positive integer which will divide this sum. So 63 is dividing it, and so option number 32 is gone, option number 60 is gone, 63 is right there, and 65 is yet there. And what we have done here does not prove that 49 to the power 65 plus 1 does not divide this sum. If it does not divide this sum, then only we can go with this answer, right? But we will have to check for this, and how to deal with this. So I was thinking about it, and then I came up with this idea. I mean, before I saw this thing, I got this idea. I'll show you. So this is your sum from 149 and then till 49 to the power 125. So I start making pairs, and I start making pairs like 1 and 49 to the power 63, and then 49 and 49 to the power 64. So the powers are 63 apart, okay? So if I pair it like this, I will get 1 plus 49, this 49, and then 64, and then this, and then eventually I will reach 49 to the power 62 and paired with 49 to the power 125. Notice that there are 126 terms here, right? So the middle term is 63rd term and 64th term. So you can keep a track of whether you have completely made a pair or not. Because there are 126 terms, you will get 63 pairs. So yes, you are getting 63 pairs, because look at the first term 149 until 49 to the power 63. This is 49 to the power 0, and you are reaching here 49 to the power 62. So you have got these 63 numbers. So we have got 63 pairs. So that is fine, and then we can you can see that we can take 49 common from here. We can take 49 square common in this part, and then finally we can get 49 to the power 62 common, and then I get this thing, and then I get 1 plus 49 to the power 63, and then this part, which is definitely an integer, which is same as before in a different way. So we see that 1 plus 49 to the power 63 is a factor of this sum. How about if we start pairing in a different way? So if we start to pair in this way, we take 1 and 49 to the power 64. Okay, and then we take 49 and then we pair it with 49 to the power 65. This way I will get a common 1 plus 49 to the power 64 each time. You see, this thing. So these powers are, you see, this is the power here is 49 to the power 0, this is 49 to the power 0, and the powers are 64 apart. So here you have a power of 1, then you have a power of 65. So when you will be pairing the last one, 49 to the power 125, you will have 49 to the power 61 here. So you will reach here and the pairing will end. So these two terms which are in the middle, 62 plus 63, they will be left out. So I have written it here. Take a look at it. You have got to have 63 pairs. Okay, so starting from here, 1, 49, 49 squared, 49, 61, you have got 62 pairs, and then one pair, 49 to the power 62 and 63 is left behind. This is very important. And then what happens? So you can take 49 common from here, you can take 49 squared common from here, and then till here you can take 49 to the power 61 common, and this will be left behind. Okay, so you can't make this as, you can't rewrite it as something and 1 plus 49 to the power 64, you can't do it like this. So you are left behind with this term, and then you club these things up. You can take this term common from all of these terms, and you have this expression. Now what happens? You can see that 1 plus 49 to the power 64 divides a part of the sum, this part. But how about this part? And only if 1 plus 49 to the power 64 divides this part also, then 1 to the power 49 plus 64 will be a factor of the whole sum, isn't it? For example, suppose you have a number, let's say 36, and we know that 6 divides 36, and we are breaking down 36 in terms of a sum, and let's say we break it down like 30 plus 6. So if 6 divides one of the parts like 30, it should divide the remaining part also. Otherwise 6 would not be able to divide 36, right? For example, if you can break 36 as 31 plus 5, but then 6 will not be dividing both of the parts, so then that's okay. But if you break it down 36 like 24 plus something, 24 plus 12, so if one of the part is divided by 6, then the other part should also be divided by 6, right? Which it does here. So I am using that kind of a logic, and if 1 plus 49 to the power 64 divides this part of the sum, it should also divide this part for 1 plus 49 to the power 64 to divide the whole sum. If you don't understand this, pause the video and think about it. Then what happens? Then we are comparing this part, and we are thinking that this number is this 1 plus 49 to the power 64, and this number is this, and we have to check whether this thing divides this thing or not. Well, the answer is very interesting. Which number is greater? Let's see which number is greater. So we can rewrite this 1 plus 49 to the power 64 as 49 to the power 62, and this, and we can write this number as 49 to the power 62 common and 1 plus 49. So this thing is 50, 49 to the power 62 multiplied by 50, and this is 49 to the power 62 multiplied by a much bigger number. 49 square is going to be much bigger. This number is very small, that's fine, but this part is definitely greater than 50. So this number is 1 plus 49 to the power 64 is greater than this number. So this is a smaller number. So it's like 5 is greater than 3. So 5 cannot divide 3. Right? If you divide 3 by 5, you'll get something smaller than 1. So definitely 1 plus 49 to the power 64 cannot divide this remaining part, and because of that it cannot be a factor of the whole sum. Similarly, you can think about 1 plus 49 to the power 65, because that is in the options. Okay, so let's think about that. We have 1 plus 49 squared, and we have 49 to the power 65 here, 66, until 49 to the power 125. So if I start pairing like this, I get 1 plus 49 to the power 65, then I'll get 49 plus 49 to the power 66, and you see that there is a gap of 65. So when you reach the end, when you're pairing 125, you'll get a gap of 65. That would be 60. So 49 to the power 60 plus 49 to the power 125 will be paired, and then you will be left with 49 to the power 61, 49 to the power 62, 49 to the power 63, and 49 to the power 64, right? All these numbers you will be left with. Okay, then what happens? You can take things common. And you will be left with this sum. Plus this thing here. So 1 plus 49 to the power 65 will divide this part. Will it divide this part or not? So just take a look here. What you need to do is you can take this 49 to the power 61 common from here, and you will have 1 plus 49 plus 49 square and 49 cubed. And if you take 49 to the power 61 common from here, you can have plus 49 to the power 4. And you have to prove that this part and this part, you have to compare these two parts, and you have to figure out which one is greater. So this part here is 49 to the power 4 minus 1 by 48. this is smaller than 49 to the power 4, and this part here is greater than 49 to the power 4. So this number is greater than the leftover, this part. Because of this, this number won't divide that part. You can generalize it for higher terms, and that's when you can say that the greatest number, the greatest integer k required in the original question was 63. Thank you.